right. All right. Let's get this going. Popping out Twitch chat. I gotta reply to my own tweet. Cool. Okay. Hey. Let's get started. I think this camera, we want it more this way, right? No, more that way. Yeah, a little more squared up. Okay. Welcome. Where are we giving up? So I don't remember the password to my Raspberry Pi. And the plan was to take what we were building out to test the end-to-end round trip latency for our Vercel suite of functions that are a couple running in Vercel, a couple running in Lambda, some with like HTTP servers or adapters in them, sort of the gamut, and then put it alongside our other tests, and then compare them locally from a local connection over the course of like a week or so. But I don't remember the password for this thing. So I can, and I don't have, I guess the biggest problem right now is that I don't have a mouse. So I can't open a console. I don't remember, maybe I could switch over. Okay, now I've got ideas now that I'm live. Maybe I could switch over to like the mouse mode on my keyboard and use that to move it around, and maybe figure out if I can reset the password or extract the password somehow. It's a 32-bit processor. I mean, come on, we should be able to crack this, right? I don't know anything about that. Anyway, so what we've done yesterday is, where are we at? Is it 9, 10? No. Here, curler counter. Okay, so we push this commit. That's live now. It should be live. Yeah, we fixed a little bug in it. So I think what we'll do is let's modify this little function to sleep for 15 minutes and then run all the requests. And let's just get that rolling, and we'll run it on the MacBook. And then we can turn our attention to the Raspberry Pi and see how far we can get. I can't believe I don't remember my password. This is so annoying. And it's not my password manager or anything. I set this up like a year ago. I don't remember. Oh, it got me good. Okay, let's write some code. All right. So we want to do this. Boom. Tokyo time sleep. Sleep for 15 minutes. That should work. Okay. Because we can sleep, we can use Tokyo time sleep in a async function, I think. Wait until, yeah, okay, so this works. Yeah, okay. Okay, so we need to import this and sleep. Now we can just do that. Oh, what does it complain about? Wait, what? Oh, I have another duration here. It's standard time duration. Is that okay? I didn't realize I could mix and match. Tokyo has a duration too. Interesting. Okay. Well, I want to just do this. Async Rust doesn't. Hey, Regalius, async Rust is just fine. Just fine. I was gonna fix the import, but we don't have to. We'll call it fully qualified. How you doing today, Regalius? You doing well? All right, I'm just gonna export some environment variables. I am great. Doing just fine. Gotta pick up more baby stuff today. All right, so all I'm doing right now is I'm just hiding my screen because I have a bunch of environment variables. They don't have secrets in them, but they just have URLs. And I want to hide them so that they all stay cold. Oh, we need to get the Vercel URL. 1 second. Go to Vercel.com. I paid for my upgrade plan yesterday. Okay. Boom. Okay. Local cold start Vercel. And 1 second. Hey, Volley Bill. 1 second, I will unblur it, I promise. Local cold start, okay. Okay. There. That looks good. And then now we need to run this. All right, this should be running now. Okay, good. Good. Okay, we got points. Serverless HTTP, Hono, Lambda Web Adapter, AWS. Why don't I see Vercel in there? Chat. Why don't I see Vercel in here? No, what did I do wrong? The sleep seemed to work. Map.insert Vercel URL. It's there. Let me 1 sec. It's gotta be there. Yep, it's there. I don't see the result here. Nope. Regalius, I noticed 6 millisecond gap between Lambda, the web adapter, or Vercel, sorry, last week. That latency go down when you have server code. So that's a baseline Lambda function with no code, just hello world. Vercel had asked if I would try this out with like a Lambda function that also runs something like a HTTP server inside of it. Well, I agreed. That's common enough that people do it, so we should look at the comparison point. It's an interesting talking point. I also pointed out that you don't have to do that. And in Vercel, for the plain functions, most people wouldn't want a request response semantic, or well, okay, that's maybe a stretch. The plain functions still give you a endpoint. You don't have the asynchronous options that you get with Lambda, as far as I can tell. I think you have like cron, you have like workers for cron or something. But regardless, like you don't always need that HTTP server, right? Like maybe, I don't know, maybe you wanted to get like a pre-signed bucket URL, or just like have a webhook that just responds to the request but does something internally that doesn't need to create an HTTP response. So you may not need it. So we compromised and we're gonna just do both, which is fine. Yeah, we'll go back. Okay, something's not working. So we didn't get the Vercel point, and I want to know why. Map.insert Vercel URL. That should be fine. Why don't we get the Vercel point? Oh, I wonder if we got an error. Yeah. Let me hit my URL and check. 1 second. Boom. No, that looks fine. We definitely didn't hit it. Oh, what the fuck? Okay, I got a bug in my code. All right, chat, spot the bug. Oh, okay, so get function URLs map. We probably don't need to do that every time. We just need new results every time of the loop. Function name string. And we set the function name here. What did I do wrong? We didn't get no response. Hey, Kojak. Good to see you again. Welcome back. You're confident in URL mapping? Yeah, I just checked. This environment variable is in fact set in my shell, and it points to the right. It points to the right endpoint. I can dump the map, and maybe we'll just hear, yeah. We're gonna go blurry again. That's not in the map. It is not in the map. Why isn't it in the map? Hey, Hack and Soul. We wrote Rust because we're gonna run this on. We were going to run this on a Raspberry Pi, but I can't remember the password. So we're just going to try and get this running locally on my laptop. And then we can either re-image the Raspberry Pi, or I can fool around with the cables and see. Maybe we'll figure it out. We'll figure it out. Okay, but it doesn't have my, it definitely just not, I gotta have an environment variable wrong. It's right there. What the hell? Oh, this makes no sense. Okay, yeah, it's not finding that in the environment variable. I don't know why it's not finding that in the environment variables. Maybe it has a space in it or something. Let me re-export it. I know this is not so fun to watch. There we go. Okay. I had a space or something in it. Cool. Okay. All right. All better. So we need to do. Obviously, this code is now technically flawless. And we don't need this anymore. We don't need to return here. Okay, sweet. Okay, cargo build. How's everyone in chat doing? Kojak, good to see you again. Hack and Soul, good to see you again. Folly Pill, thanks for joining the chat. Welcome aboard. We are hopefully, okay, we got to figure out the Raspberry Pi thing, although I think it might be too slow, just like generally speaking. Should we guess another password? serverless? No, I don't remember. Okay, let's just get this running. Actually, yeah, let's just get this running. Oh, we panicked. What happened now? Oh, it got mad at an empty payload. Okay. Guys, Rust code doesn't panic except when it does. Hey, Bronify, Lambda Web Adapter. I'm a huge fan of that project. I've done so many streams on that. One of my favorite projects was building an Express app in a Docker container and then shipping it to both Lambda and Fargate simultaneously, or AppRunner and Lambda simultaneously, and it can run on both of them. And then you can load balance between the two. Like if you have periods of very low traffic and you want to just run it in Lambda, you can do that. Or if it gets busy, you can switch everything over via Route 53 and hit everything on AppRunner, and then you have no cold starts at all. It's pretty cool. Pretty cool stuff. And actually, we have to wait anyway. So no matter what, we have to, yeah, okay. Okay, cool. That actually will work. Sweet, okay. This should loop. This should loop. Let's do it, chat. We did it. We made progress. Yeah, where did I do this? CD stream. Yeah, okay. So I did this on stream. You can run this all locally. It has a Docker file. And the coolest thing is that this bit here, this grabs the Lambda Web Adapter and sticks it in the extensions directory. And this one's already compiled. But you don't even, like, this code is just not used at all in any other container runtime environment. So you can simply drop this project into, like push this container to ECR and push it straight into AppRunner and it will run. ALB app load balancer, yes. So AppRunner is, okay, so there's this great place where AppRunner lives. And no one talks about this because, well, they should. Where's my Excala drop? Okay, so AppRunner exists in this beautiful place of, you normally when you have Fargate, so say you want to deploy like a Fargate task. If you want to expose this to the public internet and you also want to, like, you know, do normal production deployments and other normal web stuff, you have to deploy this with a load balancer in front of it. A L7 load balancer, an application load balancer. Is this connected? Yeah, okay. So now your requests, you know, it's got to sit like this. The problem is that this little guy right here, so your requests come in, ALB forwards it on to your Fargate task, vice versa. Responses come out, and it goes out. The problem is that just for the privilege of having this thing, this is $20 a month or something, maybe 15, doesn't matter. So even if your Fargate tasks are super cheap, like super duper cheap, you're going to pay a flat rate for ALB. Now that can be fine if you host many projects in the same domain, because this is where you can like terminate SSL or TLS, I mean, and have your like domain name and then everything else from here is like internal IP and network groups, security groups, and VPCs. You got to pay. You're eating the $20 a month. So if you're under that cost, but you want to work on containers, you can just AppRunner is effectively the same thing, and you just get like. You can just say your container, your LB. This is all contained by AppRunner. You get this all, you get a load balancer for free. So that's why I'm a fan of AppRunner, because it fits this really great niche where you might have steady enough traffic that's still low volume that you don't need a ton of compute. Think like a webhook server, right? If you're or you want to do like a Twitch, you know, real time kind of chat thing that you don't need cold starts. You can run AppRunner. I think for it goes down to like $5 or $6 a month. And then you get a load balancer for free. You get rolling restarts. You get you can hook it up to code build and just push straight from your repo. You get like kind of like that Vercel experience inside of AWS, and you just get that free. And then when you outgrow it, you can put your container straight into Fargate, and it runs just fine. Or you can put it on EKS or something if you want to, I don't know, get hurt, get hurt by by K8s. So I'm a big fan of that. I'm a big fan of App Runner. I do think they haven't released anything for it for a long time, and I'm a little worried they're going to shut it down. So go off and start using it for hobby projects, because otherwise, we're gonna lose it. SSD container or App Runner? I don't know how SSD runs containers. My guess is it's Fargate tasks. I should just ask Dax. I'll send him a note. I don't know how they run Far. I mean, we can crack it open and look. Yeah. So, okay. This is great. This is running. Okay. Yeah. Would recommend. Yeah, we can even look more at this. The app is super simple. We process in this case, we have a signal handler, which we don't care about for the purposes of Lambda, but we do care about for the purpose of App Runner or locally. Cloud Runner's container does it right. I wish there was an equivalent in AWS. Yeah, Cloud Runner is excellent. I'm a big stan for Cloud Runner. I think it's a great product. Cloud Runner. Cloud Runner is a great product, and I follow I'm so sleepy this morning. I follow the product manager on Twitter, and I've interacted with him a bunch. And it just seems like a really good product. Okay, yeah, that would make sense that SSD containers Fargate. The only problem is that like everything else in Google Cloud sucks. Cloud Run is awesome. And Cloud Run also, okay, there's another thing that I like about Cloud Run is that you get 2 pricing options. So they have on demand and pay per use. So you can get a tier with jobs where it's always running. Yeah, he's on. It's I know the App Runner PM. I think it was Janak was his name. He's on Twitter. No. I think he was on Twitter. No. I don't know. I'll have to find him. I probably spelled his name wrong. He's super cool. I had drinks with him at reInvent. We had a long chat over several old fashions about App Runner at reInvent. Cloud Functions v2 gets transformed to containers using build packs. Okay, I have not explored build packs that much, Hack and Soul. I've heard about them, and I've seen people I have a couple friends that are into it. I haven't used it. Why I'm a fan of Cloud Run. These 2 pricing tiers are pretty awesome. So you get the serverless pricing, only pay for what you need, and then you have this like request dimension. And yeah, you get 2 million requests per month, which Lambda gives you 4, but whatever, right? But then if you want always on CPU, so you don't have any cold starts at all, you can just get this, and it's just like a slight difference in VPU second, but it's not provision concurrency. Like, I still get that auto scaling. It's not, I just don't have to, like, I can just say, okay, I want like this amount of CPU minimum allocated. I believe is how they set this up. So, and then yeah, they've got like committed use discounts and all this other stuff. Drawdowns, the crazy stuff that makes tech businesses run that we would probably never think about as engineers, but they are all over the place. All right, people are trolling me on Twitter. Baruzu wants me to try the password skill issue. I doubt it. I don't think that's it. If this works, I'll be so happy though. Negative captain, permission denied. Should we format the Raspberry Pi? Is that just the way to go? I think it's pretty fast. Because I think I can, when I format it, I can set up SSH. I think we just do that. Let's do this while this is running. What version do I need for this? Raspberry Pi 2011.12. Okay, let's find out. No, this is a very old one. Model B revision 2.0, baby. This is it. This is it. This is the one. The B plus. The blessed hardware. It's a 32-bit processor, baby. Let's go. A powerful GPU, chat. It can do 640 by 480. 512 megabytes of RAM. That's more than my Lambda functions. Oh, 700 megahertz processor. That is so much. You would never need more than this. All right, let's wipe it. I think is it 32-bit? I'm pretty sure it's a, yeah. What version? Oh my God. Raspberry. Oh, should we ask Perplexity? I think it's 32-bit. What? Oh. No, not a 3B plus. It's not a 3B plus. I don't think so. Right? I do not think it's a... I'm pretty sure it's a 32-bit processor. Specs. Is it here? Maybe it is 64-bit. Let's find out. Let's put the 64-bit on it. Oh yeah, we have to reply to Dave. This did not work. Okay, let's just do this one. And let's get this guy going. There we go. Right. Edit settings. Oh, wait. I have an authorized key, don't I? Oh. Wait, the password's right here. How do I get this setting? Okay, hold on, chat. We found it. Okay, so it didn't work because I had an authorized key for my... Oh, this explains everything. So, okay, my SSH password is random, but I had set up a known host for an old machine that I used to have. And now that machine is gone, so that's why this isn't working. But I have the password now. So, okay, first off, we have to... Can I drag this? Okay, I'm going to just drag this and copy the password. Yeah, it's a giant random... Oh, no, I can't highlight. Chat. We're doomed. I can't... Oh, I can. Okay. Okay. Let's see if this works. So we don't have to reformat it, although it is running a 32-bit OS, I think. Let's find out. Okay, we're going to boot it up. This is going to take a few minutes. Sweet. And we should have another ping on that. Okay, while this boots up, I've got the password. I'm going to blur my screen, set it in my shell. Okay. We've got it. We should have another ping here soon. Okay. One ping, please. Sweet. If this is a 64-bit OS or chip, though, we should definitely get the 64-bit OS on it, because I think running it, like compiling all of that stuff from Rust might be really hard to find the right tool chain for it. We'll find out. Okay, cool. All right. Yeah, so that's Cloud Run. Big fan of that service. Love that a lot. We got this working too. We're running this in a loop every 15 minutes. We should probably just commit this code too. This is all open source, chat, so you can all read this if you want to read my silly Rust code. We don't want to interrupt that. My .env. Okay, good. What do we change? We put this in a loop. That was it, right? Yeah. No. Okay, sweet. And then the next thing we should do, now that we're using Tokyo, is we should run this concurrently. So all of these right now, we just have like, we're awaiting each request in this loop. Or we're not even awaiting it. I mean, we do, yeah, sorry. We await each request in the loop. We should create a vector of promises and then await all of them concurrently and then run, because each request may get slightly different routes, and we want them to have the same, I mean, they still might get different routes, but if we can locate them around the same time, I think we'll have a better, result. I think we're more likely to get the same path through the network for each of them to their respective destinations. Okay, is this up yet? Ping Raspberry Pi. Hey, we got a response. Okay, yeah, that should work. I think I still have a copy. Oh no, I don't have it copied anymore. Okay, one sec. Come on, work. Oh, is it working? No, what? Permission denied? Really? No. Okay, we gotta wipe it. We gotta wipe it. Okay, we'll wipe it. We'll get it going. Regalia's best Zelda game? I mean, I played them all. I would say Ocarina of Time is my favorite just for nostalgia's sake. And then probably Breath of the Wild and Tears of the Kingdom. All because those games just like were a whole new level of Zelda. The nice thing about this Raspberry Pi is you can just yank the power out whenever you want. Okay. We're going to give it a much easier password. Tears of the Kingdom? Yeah, it's a great game. All right, I'm off screen right now because I'm setting up a password for the new Pi. For some reason, it had the wireless setting as Great Britain. Oh, that's right. That's where it's from. One second. Okay, my own fault for this. Okay, we're writing. Yeah, Tears of the Kingdom is a great game. Arguably amazing. Oh, hey Taco. Dog decided to come say hi. Hey, buddy. Hard to see there, bud. Come on, buddy. Come on. All right, I guess I'm gonna hang out for a minute. All right, we are formatting. Oh, there we go. We got new points. There we go. We got some points. Okay, let's look at our first local points for this Vercel test. Oh, did I get logged out? Okay, one second. Yo, Marco Snills. Thanks for the follow. Why are my alerts not working? What did I break? I broke something. Thanks for the follow. Let me log into AWS account. Need a two-factor. You always got to be two-factoring. Okay, 663-647. Nobody leaked that. Nobody tweet that. All right, we're in chat. We made it. Okay. Northern Flicker, thanks for the follow. That one worked. Marcos, I'm not sure why it didn't work for you. Thank you both. Welcome to chat. Thanks for the follow. Thanks for hanging out. Oh, thanks for the heart too. Chat, my mom saw the stream on YouTube and she sent me a nice little note. Error downloading, stream closed. What? Why did, okay, well, apparently that failed to download. We'll see. Okay, we need more metrics. All metrics. I don't care about these. Local metrics. Vercel. Oh, not Vercel. Yeah, we want, okay, awesome. We did this. Okay. So what do we got? Let's go in order. So it should be AWS should be fastest. No, this is, why is it 1 week? We shouldn't have 1 week of data. Oh, we don't. It's got all these other, oh, because they're all still graphed. Clear graph, yeah. Should have 1 point. I don't have any points for this. Now this is confusing. Options, number, do I have any data? None. Oh, I don't want trim mean though, and I don't want 1 hour. Yeah, there we go. A trim mean is, I guess, fine for this, but yeah, it probably trimmed it trimmed the only points. Okay. Yeah, so this makes sense. Like, this is where we're at so far. It doesn't matter because there's literally only 1 point, so we can just look at the maximum. So AWS is the fastest, a plain Lambda function. This is again for my home laptop. It's running, I mean, we're on a gigabit network, so even streaming, it's fine. I don't care about the upload or the download though. I care about how fast can we get the okay. So we have like a 3 millisecond ping. That's plenty fast. Symmetric gig, let's go. So AWS first, and then Hono again, and then Vercel, and then serverless HTTP, and then the Lambda web adapter takes a while. Now the Lambda web adapter is going to be slower anyway because it does this like liveliness health check probe. I think you could rip that out. I think you can disable that entirely if you wanted to. And that would be, that's an option that we could look at for performance. Maybe we could submit a PR or fork it, but that's totally an option. But so now we're collecting this data. So we should let this sit. I'll for sure let my laptop sit during the stream today. And then I have to figure out, do we image this yet? Okay, good, we're writing. Then we'll get this plugged in and we'll get this sitting and baking, and we have to figure out how to compile for Raspberry Pi. So maybe we should do that first. So hopefully this will work. What do they do? What's the state of the art for Raspberry Pis now? Oh, it does have a 32-bit CPU. Dang it. Okay, so we got we have the wrong OS. All right, rewrite. That's fine. Can't win them all, chat. Quieter group here today, but if you're just joining for the first time, hi. I'm AJ Stivenberg. I work as a staff engineer at Datadog on serverless stuff, serverless observability, performance, and distributed systems as well. I also am an AWS serverless hero, and in my free time I write about and blog about and talk about performance, serverless performance. So what we've been doing the last probably 3 weeks on stream has been trying out Vercel, and with Vercel's kind of function as a service offering, which is built on top of Lambda, we've had this running, this end-to-end latency test running for the last several weeks. The biggest reason we test end-to-end latency is because the metrics that Lambda gives us is insufficient for determining the full impact of cold starts. Most importantly, the time to copy bytes into the sandbox is not considered as part of their metric for it's not considered as part of their init duration metric, so we have to test end to end. What we had been doing is testing inside of the same region. Now that means that our Lambda function that is polling these endpoints is in one of the availability zones in US East 1. I think it has 5. I should answer this actually. How many AZs are in US East 1? 4 AZs. So there's four availability zones here. I wonder why not 5 or 3 for consensus reasons. I guess it doesn't matter so much because you can just have separate nodes. Is this right? When was this updated? Regardless, that gives us the lowest latency. These are all connected by giant internet backbones between each of the buildings. They're separate buildings on separate floodplains with separate power supplies. Kind of interesting. But the whole purpose is to be as highly available as possible. So what you end up with is a situation where our Lambda function spins up. It talks to 4 other Lambda functions, and then also it talks to Vercel, which is also hosted in Lambda. However, Vercel pointed out they have Vercel architecture. Vercel runs their own CDN, and I believe they have their own like web application firewall in front of this. I'm pretty sure their network, they're using AWS's global accelerator. So my hypothesis is that this request never leaves AWS's network. We could probably run a trace route from Lambda or from like an EC2 instance to like a Vercel function to find out the path it would take. But my guess is they're using AWS's like global accelerator network, which improves performance for routing clients from wherever they are to getting it into AWS as fast as it can and then matching you to the closest region that you are. In my case, that's US East 1. So that should be pretty fast. I don't expect there to be much network overhead. And then Vercel runs like this fleet of proxies, and they also have, like I said, the web application firewall, which is running in Kubernetes. And then it determines that like this request is going to go to a Lambda function, and then it routes it out to a Lambda function here, the serverless functions. So there's a little bit of overhead there. Overall, I think they do a pretty good job. You can see by the metrics. There's like our base Lambda latency in the blue. Quit pushing the pop-up over it. And then you can see like the Vercel latency in green. So when we compare the two, it's pretty good. There's some back and forth. But it is pretty close. So I think they're doing good, given that you have to run some code on top of it, right? Like you can't, the fastest code is no code at all. So. Boom. Okay. We're still ready. Good. Oh, we wrote more points. Oh, no, we didn't. That was the last one. Okay. That's up. That's up. This all looks good. The other thing they wanted me to test. Hey, Marcos. Welcome to chat. We briefly exchanged DMs about the... Hey, that guy, Doru. It is me. Any ideas if the Lambda public function URL also goes through Global Accelerator? Okay, so let's talk about Global Accelerator. So all Global Accelerator is going to do is get your request from wherever the customer is to their network, like AWS's network, as soon as they can. Here, let's.
Whether your users are local or spread across the world, you want them to connect to your applications as fast and reliably as possible.
True.
Routing their traffic over the public internet leads to inconsistent performance.
Exactly.
So you need something better. AWS Global Accelerator improves the availability and the performance of your applications with local or global users. Global Accelerator uses the vast, congestion-free AWS global network to optimize the path from your users to your applications, improving the performance of your TCP and UDP traffic.
Okay, so they are going to, when a route could run over the public internet into their data center, into their like regional intake or their AZ level intake, they will instead push it onto the closest availability zone they have, or maybe even it's a point of presence, like the closest edge, and then push it onto their own network. And their network has more capacity than the public internet, so it's faster. That's the idea. What would a function URL do? Like, that's a great question that I don't even know if they would talk about. My guess is no, that they don't do Global Accelerator at all. It's just not a part of the product offering. You could probably put your function URL behind Global Accelerator. I also think there's a certain amount of, like you want a global static IP. Like there's some other routing tips that you get as a result of it. Like they run your DNS for you, so you can have like one IP address and it can route anywhere in the globe. I do think. I wonder how many people are using the API accelerations features, because yes, like it says, we'll bring back the music. You get you get faster TCP connections because they make that connection straight to the closest building towards them, and then everything else is over AWS's backhaul fiber or backbone. Oh my god. And then the TCP termination at the edge just means you have like less overhead on the line between that endpoint and your server. And we can talk about eBPF too. I don't think that they're ever going to support it. So eBPF is a super cool, it stands for Berkeley Packet Filtering, and it lets you run a little program in a sandbox inside the kernel, and it can read packets right off the line. So instead of switching into user space, which we talked about this yesterday, kernel mode, user mode switches are expensive in terms of time. And what you can do is, what you can do is kind of reduce those using this type of program. It's similar to how we talked about yesterday. You can use mmap with IOU ring to allocate space once and then write bytes from the kernel straight into kernel space and then read them from user space without a kernel mode switch. It's super useful. I think for like a observability standpoint, it's probably where it's most popular, and that's my experience with it. And the reason is that we can see, like, we can install one kind of wrapper at the kernel level. So on any of your pods that can run any of your other, I forget exactly how it works in K8s. I think you can actually have a listener in the, like you can forward all eBPF traffic to one node. But regardless, like in a normal, VM instance, you can just spin it up once in the OS, and then the kernel will load your program, and you get like tracing straight out of the box for all of your applications running on that OS, because you can look at all of the web requests that are being sent or received, and you can modify them in flight. It's also very popular for security, because you can have like a instead of having to like in your application install, or like at your OS like install a firewall, you can have it built into the kernel. So just like anything talking to a non-allow listed IP address can just get blocked, like at the hardware level. There we go. We got another point. All right, let's see what we got. So I don't care about these. Now I want the no more PCAP pain. I think there's still PCAP pain. Hey, we got a little bit better. Where's our first Vercel point? I mean, the results are almost identical, right? Like we have almost the same results as before. Oh, I wonder, did our Vercel not cold start? That might be why. But that looks good. I mean, everything is trending downwards, which is always nice. Even the Lambda web adapter improved significantly on that last point. So our last points, AWS 441 milliseconds for my laptop, Hono 42, Vercel 520, serverless HTTP 624, and Lambda web adapter 756. So that's more or less what I'd expect. Like, I think the results are already showing that they're in line with exactly what we were getting from within Lambda, even though it's running from my laptop, because that's the exact same order these come in. It's the exact same. Very cool. All right, is this done? Verifying. Okay, I don't know what that means. Probably just running MD5 checks. Marcos, have another one for you. How about also measuring how long the direct invoke takes? Yeah, we did that already. A whole other project I did. I'll plug this in chat. We did this over the last like year of chat, or of streaming. This was what I used for my my reInvent talk. Is we just did direct Lambda invoke. So we would do an update function configuration to invalidate any running sandbox. It would basically cause a cold start everywhere. And then we would use a Lambda client via HTTP. The only difference, if you look at this request, you're sending it, you know, like my guess is there's almost no difference. We can test this. We can put this in the benchmarker and see like what's faster, direct invoke or just a function URL, but my guess is it's identical. I'm guessing whatever they whatever mechanism they hand to call the invoke plane via the AWS SDK is the exact same like thing you're getting with a function URL. You're just not having to sign the request. I did one of these Invoker. This is a fork from somebody sent me this project, but there is another Rust project, and this doesn't use the AWS SDK. It just uses it signs the request like using HMAC itself, and then it's just lambda.region amazonaws.com, and then you send the what's the parameter? Is it just /? Yeah. So here, this is the request you get. So my guess is all they have for function URLs is like a teeny tiny thing at intake that translates this, and I doubt like. It doesn't have to, it's not like it's a proxy. It doesn't like make this request. It's literally the same server that fronts this is fronting a function URL, and it just has a different route. So I'm sure that I would be shocked if it's different. We can test that though. And yeah, if you haven't signed your own AWS request, you should learn. SIG-v4 is cool. It gives you a hash of specific headers you have to have, and then you sign them all and you include that, and then they have a timestamp for it. So that's one of the ways they can verify that you're not like using a replay attack with old credit or like with an older expired token. Verifying. Chat, we are verifying. I don't think, yeah, because there's no way Raspberry Pi is going to run OBS, so I'm not going to get a stream. I could put my camera onto the screen, but I think it should just boot and have SSH headless, so I shouldn't need to run anything else. But now we know the password. We're rocking and rolling today, chat. It was a slow start, but we did it. You can now eject the SD card. Okay. All right, let's fire this bad boy up. 2011's best Raspberry Pi. Okay. It is loading, and I've got the credentials, and it should have everything for my network connection too. Yeah, Marcos, yesterday's stream, we looked at the data for the first time. So just a quick recap. We had been talking to Vercel about creating a end-to-end latency benchmark test because they recently improved the performance of their Lambda. They call it a bridge. I would call it a wrapper. It's written in Rust now. Very cool, very fast. And what it does is it communicates with their like data plane basically. So they're doing direct invocations of Lambda functions, and they're running their own like web API around it. And then we wanted to compare that against how AWS does it. So we set up this whole test plane, and what it is a Lambda function in the same region. Where did I do this drawing? Yeah, so it looks like this. We have a benchmark function running in US East 1. It should be in this. It's in the same region. It's going to be potentially in a different availability zone, like a different physical building, but in the same geographical area. And it will invoke both a plain Lambda and a plain Vercel function. And we have a few of these. So we've created one with Hono, one with Lambda Web Adapter with Express, one with serverless HTTP with Express, and then one just very plain, Lambda function as like a baseline. They all return the same response envelope. And they do that so that we can figure out whether or not it was a cold start. Then if it is, we measure the latency from the perspective of this caller, and we emit a metric to CloudWatch. So yesterday we looked over this data, and then I shared it in the tweet, but basically like the fastest obviously was the baseline AWS. The second, or the fastest of the HTTP options, was Hono, which is also very consistent, very impressive to see. Then Vercel, then serverless HTTP, and then the Lambda Web Adapter. And like the Lambda Web Adapter especially, like that's sort of what we expected because there's like this long there's a long history there, but it does, the whole purpose of the Web Adapter is that you can take an existing HTTP server that you have running anywhere and drop it into Lambda with no changes. And that is like, to make that work is pretty big. It has to rewrite that entire event as an HTTP request and make it, whereas something like Hono or Vercel gives you the facade of that, but it doesn't actually recreate all of it. So there's just more copies, more bytes, more buffers to copy around, more mem copy operations effectively, and that takes longer. So no real surprise. Oh, you were a Zeit developer. I remember when they switched, it was Zeit.now, and people were mad. People loved the name. And now I think there's a whole generation of developers that have never known it as anything other than Vercel. All right, should we ping the network? Come on, you gotta go. I don't know how to pull up the... I don't know how to pull up the Raspberry Pi without really messing up OBS. The activity light's not on anymore, though. I don't think it's Raspberry Pi.local anymore. I changed the host name. It should just be Pi.local. All right, we're going to restart it. Yeah, and then the Vercel folks, we've been in contact over and over again. They had also mentioned, so like the first thing they asked was like, can you test with an HTTP server? I said, sure, no problem. I'll put a couple together. We did that last week. We let them run for the week. We talked about the results. Then the other thing they asked was like, well, we have this, we have more networking. We have a WAF, we have a CDN. Can you test it from a local network? Because like the Lambda request may run entirely on AWS's network. And again, I thought that, I was like, I think the Vercel request also runs entirely on AWS's network unless you're using some Cloudflare, which they may be. I don't know. They didn't really say, but I'm pretty sure it's Global Accelerator. And so then we're like, okay, well, we'll test from a local machine. So instead of just using the JavaScript I'd already written, we wrote it in Rust, and then we've got some points already today. So, and it's the exact same relationship. So not a real surprise so far. We're gonna let this sit and bake, and we'll find out. I'm gonna have to pull up this. We'll give it another second. The activity light's still flickering here. But it should be headless. It should be ready to go. Yeah, no problem. Hey, George. They just wanted you to rewrite it in Rust. I mean, I wanted to rewrite it in Rust too. Not that that's like that special, right? Like we created a hash map. We make this request. We can pull it up in another window. Like there's nothing to this. You know, we've got kind of 3 libraries. Tokyo, because we have to use it for the AWS SDK. Searday to serialize and deserialize JSON, and then request to make an HTTP request. And then, yeah, the CloudWatch library. So that's it. There's nothing to it. We iterate over all the function URLs. We should make this a one-shot request. We should do all of them in one shot. And then we just send the response via one put metric response. I would say, so one of my complaints, I think, with the AWS SDK is that it's pretty heavy by default. It's just got, like, they're using this library called Smithy to generate SDKs from a giant, like, JSON specification. And I think it's just quite heavy and quite ugly to work with. And I want them to go back to the days where they have real library authors writing real libraries that are actually ergonomic and useful. Oh, the Wi-Fi light just lit up. Oh, I guess it strikes me that I haven't seen a... my Eero hasn't told me that it connected. Normally I get a ping. Might have to restart it a few times. Totally, Regalius, I totally agree. But they also, you know, it's like have like $1 trillion run rate, so they can afford to hire a team to write an actual SDK. And they already do have to make some changes manually. Oh, we got another point. We got another point. We got a third point. Whoa, look at that. All right, Hono and Vercel are really starting to edge in on each other here. Okay, so AWS, 418 milliseconds. Hono.js, 470. Vercel, 42. Serverless HTTP, 624. And then LWA, the Lambda Web Adapter, 754. That is a great result so far. 3 points. We can tweet this too. This will be a good tweet to have later today. When I run out and pick up more baby stuff. But that's great. So I'm quite pleased that this is consistent so far. Even from my own laptop. I expected it to be. I think if it wasn't, I would be very curious, especially if the Vercel point was wild, right? Either high or low. That would be a suspicious result, and I'd have to dig in to figure out why. But, I mean, we should probably dig in to figure out what's going on anyway. Make sure we're not confirming our own biases, because, again, this was my expected result. But I do think overall this is pretty solid, and we're going to let this run, and hopefully we can run it on our Raspberry Pi. I still haven't gotten a network ping from it, though. I double-checked the password. I know it's right. Oh, there we go. We got a ping. Did we get it right? Come on. No, I just set this up. I know it's right, chat. I promise it's right. Oh, I have to, this is why. Chat, did we do it? Is it just... No! I'm looking at it. Why? Oh, we did it! We did it. We SSH'd. Kojak, thank you. Thank you for the vote of confidence, everyone. Chat is going wild. We SSH'd correctly. Look at this. absolutely no warranty to the extent permitted by applicable law. Whew. Huge. Huge, chat. What a win. What a win. Hell yeah. Hell yes. Okay. Rust, Raspberry Pi, 32-bit. How do I... Oh, curl bang it. That looks good. All right, we're just going to blast this straight into the root shell. Yo, UJSTOR. Welcome to chat. Thanks for hanging out. We're going to install Rust on this Raspberry Pi, baby. We are cooking with gas. We're flying now, which is good because I didn't expect to have to re-image my Raspberry Pi this morning. Brutal. But good. What does it say? Custom installation, ARM, unknown Linux, GNU. Yeah, that's what it detected this. That's correct. Boom. We are flying now, chat. ETA 12 seconds. The fastest 700 megahertz processor anywhere. Actually, literally signing these TLS requests is going to be noticeable. Yo, Ultras for the win. Thanks for the follow. Welcome to the stream. Thanks for saying hello. Hi, YouTube. Looks like there are a few of you over here. We are running. Let's roll. Chat, I cannot believe we SSH correctly. That was just the bee's knees. Peak emotional drama here. ETA 17 seconds. Oh, why did my ETA go up? We don't like that. That's not good. 22 megabytes. Oh, it's okay. These JSON responses are light for our raw request response. So we'll see what it is from the Raspberry Pi. If it's like really bad. So I've been talking with the people at Synology and we're going back and forth on a partnership potentially. And hopefully they would be able to provide me a device that has like a 2.5 gigabit networking. Which is fine. Again, of course, like my connection right now is gigabit, but I'm hoping to get a 2 gig connection. And then, yeah, I would need to have a faster network device, a faster NIC to take advantage of that connection, that pipe. And then we want to do response streaming, which is why we're going to need a bigger pipe, right? That's why we're going to need be able to shove more bytes. See how fast we can write like 10 megabytes or something versus because like Vercel re-implemented their own response streaming. They had that out before Lambda did, which I thought was pretty cool. You know what? One thing I really want Vercel to do that they're in the position to do is to do request streaming as well as response streaming. So right now, I have to like push a whole chunk of JSON or a whole chunk of binary data into Lambda, and then I can stream a response out as I'm ready. That's neat, but I would love to be able to stream the request in as well. So I could just send a few bytes and start working on something, especially for like media conversion. Maybe you wanted to make clips out of Twitch chat. Like you could do that in Lambda much more easily versus like upload the whole thing to S3 and process it, right? Like that's an option. Yo, we are rolling. Cool. Vercel versus Lambda, like in Lambda Labs. Hey, Thomas, welcome to chat. I'm not sure what you mean by Lambda Labs. We're using AWS Lambda. Amazon Web Services. Thomas, type what you mean. I'm going to use the bathroom really quick, and I'll be right back. I should be ready to go soon. Oh, right, I'm back. Lambda Labs AI cloud company had something close to Vercel. Maybe. Lambda is a great name. Very popular. Are we done? No, we're still building. Okay. Rust docs. We don't need documentation. We have Copilot. Oh, we won't have Copilot on this box. Oh, that'll be so painful. This should work. Okay, so we should be able to compile. Hell yeah. We are cruising. Cool. I think we're very close to completing everything that Vercel had asked. And I want to be clear, it's not like they gave me a list of demands or anything. They didn't at all. Guillermo was super cool and had a bunch of totally honest questions. Yeah, Marcos, Rust does support cross compilation. However, it kind of sucks. So I mostly use Zig build. So Zig has incredible cross compilation. And okay, so that's not it. The actual compiler for Rust is going to use like your system toolchain. So Rust C will call out to like LLVM or Clang or whatever you have. And it uses your system linker as well. And the one on Mac OS is kind of crummy. Whatever version of Clang is on my laptop kind of sucks. And it was really hard to compile to x86. You know, I'm on an M1 Mac ARM machine. So I use Zig build as well. And that's pretty common. Rust Zig build. So there's this whole project, great project, for cross compilation that uses Zig's cross compilation toolchain. Thank you, brain. Instead of Rust. So you install Zig, you install Cargo Zig build, and then instead Cargo C or Rust C, the Rust compiler, will call out to Zig build for compiling and linking, and it's pretty awesome. So this has been working great for me. Although the reason I don't think I can compile for the Raspberry Pi, I think it's got that weird ARM v6 chip. So I'm gonna have to compile it on the Raspberry Pi, which I'm sure that'll be super fast on a 700 megahertz chip. What's the fastest a human eye can see? It's like 60 or 120 hertz or whatever. Like, what does everyone say? Everyone says it's like 60, but I think it's faster. I wonder if you had a light, you could actually see this poor little Raspberry Pi CPU. THDXR, welcome to chat. THDXR. We're gonna go ahead and just pin that. Welcome, Dax. I told Dax to come because I wanted to show him these results. So Vercel asked for me to test this on my laptop, and we've been running it from my laptop. We're gonna run this on a Raspberry Pi whenever it finishes installing Rust. Oh, we just got more points. Hell yeah. So the results are extremely similar to what we saw from Lambda. So as a refresher, here's the order in Lambda. I think the colors are a little, no, the colors are different, so don't freak out. But it goes AWS in terms of fastest to slowest. It goes AWS, then Hono, then Vercel, then serverless HTTP, and then Lambda Web Adapter. So that's the order. We have the exact same order. So the first is AWS. That's the fastest, obviously, plain function, nothing in it, just returning a little response envelope. Then there's Hono, and then Vercel, which is now rapidly approaching Hono in that last point, but it was, you know, a fair bit, a good 40 milliseconds slower in the earlier one. And then serverless HTTP, and then Lambda Web Adapter. So very similar spread. Thomas, these are end-to-end cold start request response times. So they're running from my laptop. It makes a request into either a Vercel function or any of these 4 Lambda functions. And then it gets the response, and it verifies that it is in fact a cold start. One of the things that Vercel does is warm up your functions for you. So you get that, you know, you get that experience. We should VIP Dax. There you go, Dax, you're a VIP now. You missed it. Somebody gave out a bunch of subs yesterday, and basically because I didn't have very many, nobody was watching. There were a couple lurkers that got subs yesterday. That was pretty funny. Yeah, so this is, we should get a 4th point pretty soon. and then we can see. But this is just the actual results. I'm looking at maximum, but it doesn't matter because there's only 1 point. This value, the statistic value, makes a lot more of a difference once you have a like many points in the same second. Correct, Thomas. So Lambda, for Lambda specifically, scaling is an online activity. So Lambda will use this service called Firecracker. Yo, thanks for the follow, me shock. Lambda uses these micro VMs called Firecracker, which spin up very, very quickly. The ironic thing about this is they actually spin them up ahead of time, and then they just assign one to work your task. Oh, Thomas, thanks for the follow. So this thing is already living, but once your request comes in, it will copy your code from S3, put it into that sandbox, and then start the node process or the Python process or whatever you're running. And then it will route the request to that process and then handle it and then return the response. This, of course, like in a traditional load balance server, you would do this before you put it behind the load balancer. So you have plenty of time to spin up your application. It's an offline activity, but in Lambda, scaling is an online activity. So that's what you get. With Lambda, it's similar with Vercel. Vercel does warm up one function for you, which I think is kind of cool. Kind of a nicer developer experience. But it doesn't help you. That doesn't help you if you have like a crush of traffic. If you have 100 people trying to use your application at once, you're still going to have cold starts. And that's partly why we care about minimizing them where we can. And in some cases, that does mean like running your application something other than Lambda, which I'm totally fine with. People get all upset about that on Twitter. But like Lambda isn't for everything. I know how to run services in Fargate or K8s and all these other different container orchestration systems. They're fine. Cool. Okay. Do we have any more points? 1, 2, 3, 4. Oh, we got more points. All right. Oh, hell yeah. To configure your shell, you need to correspond. Oh, and reload your path. Echo path. We got it. We can build Rust. Do we have Git? Hell yeah, we have Git, so we can clone this and compile it. We should have another point. Oh, hell yeah, we have another point. Oh, chat, look at that. Hono.js and Vercel are within 1 millisecond, 513 and 514. The drama. The drama. Okay, now we should be able to say, give me one number. Let's see what we got so far. Number. So AWS, then Hono, then Vercel, then Service HTTP, then Web Adapter. That's pretty solid. Nothing wrong with that. Very cool. Very cool and very legal. If you weren't following the very legal joke, W Rust. Hey, Cold Float, welcome to chat. Thanks for the little Rust emoji. Can't Hono do way more? It can. I just wanted to compare it to something that's HTTP-like. Hono can do a whole bunch of different stuff too. But first off, did they change this yet? No, they didn't. Yeah, so this is still a clause in here. So I have permission from Lee Rob and Guillermo to benchmark to perform this test, but otherwise it would be illegal. And I assume they would cancel and refund my $20 that I gave them yesterday. Yeah, Hono can do a ton of stuff. Hono can do way more. Hono's a great project. The developer reached out on Twitter yesterday and thanked me for the benchmark, which I thought was pretty nice of him. The coolest thing I think is that Hono can run on all of these different, like it targets all of these different things. Their OpenAPI support. Why are you using OpenAPI? Just for documentation? Damn you, crime load. Yeah, Thomas, super illegal here. Very cool, very illegal. All right, hold on. I'm going to clone this repo. We're going to clone the curler. And then we will go check out the OpenAPI support. Oh, as a joke. What? It's public. It's a public repo. What do you mean I can't? M2? No, we're SSH on a Raspberry Pi. This is the ancient 32-bit version. I don't want to jostle it because it's on and I'm SSH'd into it. Why won't this permission denied? What? Oh, we should just clone as HTTP. Oh, Git won't let me clone it because I'm not logged in. There we go. Yeah, I can't SSH because I haven't registered that key with GitHub. Okay. Will it build? Will it blend? Hell yeah. Look at it getting these crates, guys. Lightning speed. Terminal's gonna have a public API with SDKs that are way too nice for what it is. Yo, get your coffee at terminal.shop. Should we open a second SSH connection in this pane? Oh my god. Are they sold out still? Oh, it's too small. Oh, look at this animation. You guys did so good on this. This is all over SSH, by the way. If you haven't bought your coffee here, terminal.shop. It is... What is the menu? Oh, wow. About FAQ. Let's do the F. Why isn't this working? I found a bug. Doesn't work, Dax. Escape works. Quit works. Which one of you wrecked this, Dax? Press F at the main screen. I hit F. Oh, there we go. I see. You have to escape to the main screen and then do this. Wow. Will nil make me a better developer? Legally, we can't guarantee that. Is it true that your coffee contains the tears of Dax? Confirmed. You should fix that. Yo, thanks for the follow. Nod Data Academy. Nodad Academy? Either way. I'm just going to leave this connection up to see how long Cloudflare will let me stay SSH'd. Cool, okay. So the other thing we have to do is then SCP the environment variables over here and export them all, which I should be able to do. Or I can just do them one by one. Blurry screen it and run. Oh, and then we got to run that at boot too, or cron it. Hell yeah, I'm stoked that this test is coming back so consistent. Like these are great. This is a great spread of points. And of course, like we'll still use a trimmed mean P99, which we're doing over here too. And we do a trimmed mean because there's like very clearly a bunch of noise in Lambda itself. If you take a look and you just look at like P99, like there's these crazy points. Like Lambda had this like 1 point. Both Lambda and Vercel and the Lambda web adapter had points that were just wild. So that point is like one random cold start that ran up to 1.09 seconds, which is wild. The same thing, like the Lambda web adapter had one that was like 1.3 seconds, and then Vercel had one in here too, or maybe it was earlier. So we can throw like a trimmed mean, and that just says it drops the top 1%. So effectively, we're looking at like the P98 with the P99 thrown out. Because computers and distributed systems are hard, chat. Super pleased, though. Super pleased that the local tests are returning very similar results. We will see what we start. So I will stop this for a period, and then we'll start it up on the Raspberry Pi. Oh, are we done? Oh, we are building. Hell yeah. My card is empty. Check out. Oh, nice edge case checking. Uh-oh, did it reboot or fail? No, the light's still on. It just hasn't done anything in a while. Open SSL source. 9.6 megabytes. Did I download all of these SSL certificates ever signed? This Raspberry Pi is flying, chat. I think, how many points do we need before we can call this an initial result? Do we want one more point? I don't know. We've got 5. 1, 2. I guess the Vercel point is missing. We only have 3 Vercel points, but they're so consistent. Like, is that really going to change? I mean, very, very close. What was the result with Lambda from Lambda? Yeah. Okay. So Hono's a little bit faster there, and then Vercel, but only like 60 milliseconds faster at the P99. What are you hoping to see in the results, Thomas? I'm just interested in the comparison because Lambda, one of the cool things about Lambda is that it's so focused and so limited in what you can do that people who can write very well performing software, it like emerges as very obvious, and it's very cool in Lambda. That's what I'm interested in. I think it's a very cool thing to like look at something like Hono and say it does a ton, and it does it in a very small package that's very, very fast. And I think that's just like pretty interesting to explore. It's similar to the people that like run Doom on a Tamagotchi or whatever. Like, why would you do that? Well, the hacks to make things work well at that size or in those constraints are very interesting. And I think there's a lot of programming skill that goes into that. So that's why I'm interested in it for sure. So that I'm not trying to I'm not trying to like tell you should use X or Y because it's faster or not, because those factors are also depending on like what your goals are and what you're going to do with it, or like other things going on in your development world. But I'm looking at kind of all of these serverless runtimes and trying to compare. That's all. Oh, this is going to take forever. I didn't expect one compilation to take that long. Honey, what? Do we have to go? Okay. All right, I don't think I'm gonna get to finish building this on stream today because we have to go pick up more baby stuff. I do want to give away more AWS credits. So log into your AWS accounts, folks, because I'm gonna post some free $50 AWS credits in chat. Give everyone a minute here to do that. Log into your AWS accounts. Log in now. I will post it in YouTube chat. I will post it in Twitch chat at the same time, nearly concurrently, and we'll give away some AWS funny money. Everyone log in. Go ahead, build. I don't know if we're getting another point yet, but I will let this run at least. I'll let this run on my laptop for a while. We'll get more data and we'll tweet it out later tonight. We'll see what we get. But yeah, so far it looks pretty consistent. Oh, we did get another point. Okay. So Hono got a little faster there. 470 to 529. So it's very similar. It's 50 milliseconds faster, which is almost, we saw 40 milliseconds faster over the course of a week last week from Lambda. So it's very, very, very similar. And yeah, AWS continues to set the baseline. So all of this is like pretty expected. All right, all of you should have had some time to log in. All right, chat, redeem these $50 in AWS credits, please. If I come back and I see that these haven't been used, I'm gonna be sad. There we go. Go redeem it now. Redeem these AWS credits, use them, spend them on learning and knowledge, and probably not mining cryptocurrency. All right. Thank you again so much for hanging out with me today. If you're brand new or just tuning in at the end, I'm AJ Steivenberg. I work on serverless performance and all sorts of distributed systems problems within the AWS ecosystem. Hack and Soul, it looks like you got beat by UJSTOR. Congrats, man. Enjoy. spend those monies, spend those those AWS credits. Don't just sit them. Don't just sit on them. Oh, thanks for the sub, man. I don't know my, oh, there's the alert. Thanks for the sub. Spend the credits, learn. Lots of great ways you can use AWS. We're gonna go set up a raid. We'll probably raid Lana Lux. Thanks for hanging out. Thanks for the follows. Thanks for the tweets. I will get this tweet out later on and you can check it out. Yeah, feel free to DM me if you have any questions about serverless stuff. Take care, folks. Have a good one.